So this is regarding low light image enhancement technique. So next application I'm going to take is histogram. As you all know, what is histogram? Any idea? Histogram, what it is going to do is it's a graph between the number of gray levels and how many number of pixels are having that particular gray level. So you'll find the gray level distribution present in your image. Okay, since maybe normal histogram you would have everyone would have be familiarized with it. So I thought I'll take a color image histogram equalization and we'll take some application of this too. So here what I'm going to do is I'm just taking a color image and I'm going to convert the RGB image to HSI format. So RGB stands for red, green, blue, and HSI stands for hue, saturation, and intensity. So these two are standard color models, and we are having an inbuilt function called RGB to HSV of I, which will convert the RGB to HSV format. After that, as you all know, HSI in that hue and saturation doesn't contain any intensity value. Only I contains your intensity component. So I'm just going to apply histogram equalization to the intensity component alone. So what is histogram equalization is, you just like if you take a low contrast image, the histogram will be concentrated only on particular portion of the image. So I'm just going to spread the gray level of the image so that it will span the entire gray level. Okay, so that is what basically it's carried out in histogram equalization. Again, we are lucky enough in MATLAB, we are having direct function for histogram equalization, hist eq. That is the function which will carry out histogram equalization. And since here we are going to just apply the histogram equalization to the intensity component, we are applying to the third value alone. And then we are just going to visualize how the image is going to look after histogram equalization. So that's what I have done in the coding. Please have a look. I'm just reading minor image and I'm performing RGB to HSV conversion because it's going to be a color image, and then perform histogram equalization on the intensity component alone. Okay, and then I'm just going to plot the histogram equalized value and also the image before histogram equalization and after histogram equalization. Finally, this imhist, it will just plot the histogram for red plane, green plane, and blue plane before performing histogram equalization and after performing histogram equalization. I hope you are getting what I'm telling. We are plotting the histogram of red, green, and blue plane as well as the image of red, green, and blue plane. Combined together, it will be coming as a single output image. So we have got around 7 figures. We'll just analyze one by one. Let me close the previous figure so that you'll not have any confusion. Yes. So here I'm just plotting the minor image before histogram equalization, and see the contrast is very much improved after histogram equalization. That is, here what we are doing is we want to make the darker portion appear somewhat darker and lighter portion appear somewhat lighter. See here the grass and other things are looking very clearer, isn't it? It's very sharpened after histogram equalization. Here you are having certain kind of blurring, you're not able to see the details, but after histogram equalization the image is looking better. And this is how the red channel and green channel and blue channel, the histogram, it's very clear, it's not distributed evenly, it's just spanning this level, it's spanning this level, and it's spanning only this level. After histogram equalization, spanning the entire gray level. Okay, so this is regarding histogram equalization. Fine. So this are few applications of image enhancement.